To use a truth table to determine if the following argument is valid or invalid, we need to set up a truth table that contains each of the premises. So the 3 premises here need to be in the truth table, and the conclusion needs to be in the truth table. And we're going to look at each row, each critical row, where the premises are true. And the truth table needs to tell us that if the premises are true, the conclusion is always true. So that the conclusion is always true when the premises are true. So this is going to be a relatively large truth table. So let's go ahead and set it up. I have P's, Q's, and R's, so I start with those. And then I need to build each premise. So let's see, I've got some knots in here. I have not Q's and not R's. So let's do the knots first. All right, and then let's see, I'm going to start working on building this first premise. P and Q implies not R. So I need a P and Q, and then P and Q implies not R. So that's my first premise, so I'm just going to put a little asterisk there. That's an important one. My next premise is P or not Q. I already have P and not Q in there, so I just put the premise in. P or not Q. So that's an important column to look at because it's one of the premises. And then not Q implies P. I already have not Q. I already have P, so let's put that in. Not Q implies P. That's my third premise. And then my conclusion is not R. I already have it written in here, but I'm going to put it over here again so that it's easier to compare it to the truth value of my premises. So it'll be right next to it. So not R. So this is another important column. Okay, so these 3, these are my premises. And this one is my conclusion. All right, so we start, just like in the last problem, by writing down all the possible combinations of truth values for P, Q, and R. So my shortcut when you have P's, Q's, and R's is to write 4 trues, 4 falses for P. And then for Q, you do 2 of each, and they alternate. And then for R, they just alternate in singles. True, false, true, false. Okay, so now we'll just fill in column by column the truth table. And then once it's filled in, we'll talk about how to recognize whether or not the argument is valid or invalid. So not Q just changes the truth value of Q. So I'm going to end up with false, false, true, true, false, false, true, true. Not R changes the truth value of every entry for R. So I have false, true, false, true, false, true, false, true. Okay, P and Q. I need 2 trues to make an and statement true. So P and Q, we're going to have true, true, false, 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 false. P and Q implies R. So I'm looking at the P and Q column and the R column. An implication, remember, it's only false. There's 4 possible combinations, right? But like the only one that can make it false is when the if part is true, but the then part is false. So I'm looking for true, false, because that will give me a false. Everything else will give me a true. So here I have one. I have a true, false. So that gives me a false. And then let's see if I have any more. So true, true. And then everything else starts with false. So that's it. That's my only false. The rest of them are true. Next up is P or not Q. So we're looking at the P column and the not Q column. And because it's an OR, we're looking for at least one true to get a true here. So we have true, false, which is true, true, false, true, 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 false, false. So that's false. Then true, nope, P, we're looking at P. P or not Q, false, false is false. And then false, true, and false, true. So the last two are true. Okay, not Q implies P. Again, this is an implication, so we're looking for the if part to be false and the then part to be true. That's the only way you can get a false in here, is if you have true, false. So I'm looking at not Q, and I'm looking at P, and I'm looking for true falses. So here's a true, but P is also true, so that's okay. True, 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 false, and true, false. So I have two of them down the bottom here, where the if part is true, but the then part is false. So these two we get falses. Everything else is true. All right, and then finally, I'm just going to copy the not R column again. It was false, true, false, true. Okay, so now I have to identify critical rows of this truth table. So I'm trying to determine if my argument is valid, and that means that if all the premises are true, then the conclusion is also true. That would be a valid argument. If you accept the truth of your premises, the truth of the conclusion would have to follow. So I'm going to highlight rows where all my premises are true. So here's one. Okay, looks good so far. All the premises are true and the conclusion is true. But in this next row, I have all my premises are true, but my conclusion is false. Okay, so that means I've found a case where all my premises can be true, but my conclusion is false. So I have an invalid argument. Okay, and there's one more critical row here where all the premises are true. The conclusion also happens to be true, but you only need one time, just one time, that all your premises are true and your conclusion is false to tell you that this is an invalid argument. So this row right here tells me that the argument is invalid.